Let at least start in revision part. Last time we understand the meaning of moment of inertia, correct? So for understanding, first we will understand what do you mean by inertia. The inertia is Newton's first law, and the Newton's first law said every object resists change. Like if the bike is moving on the road, so if we want to stop this bike, we need to use force, correct? Because of force, the bike is stopped. So for stopping bike, we need force, correct? Because every object is resist the change. Similarly, when a car is at rest position, when we need to move this car, we require force. And why we require force? Because same Newton says every object resists changes. If they are in at rest, they want to be at rest. They don't want to by a motion. Understood? In motion, there are three types. One is called purely rotational motion. Example, fan motion. And second is called purely translation motion. Translation motion is also called straight motion. For example, cars moving on the road and they cover a particular distance, correct? And C is rotational plus translation. This means that when an object is performing rotational motion as well as they cover a distance in a straight line. The example is car tire. The car tire perform rotational motion as well as they cover a distance. Okay. So now we understand inertia. Now one more thing. If the object is now the inertia is also depend upon the mass of the object. If the mass of the object is high, the inertia is also increased. If the mass of the object is decreased, the inertia is also decreased. So can we represent inertia by mass? Yes, we can represent inertia by mass. Remember this part. Now, what is moment of inertia? So a quantity that measures the inertia of rotational motion of the body. Any method in which we measure the quantity of rotation motion inertia is called rotational inertia or moment of inertia of the body. I hope you understand this part. Now, second is a rigid body. What is rigid body? Any body whose shape and size remain unchanged. We cannot change their shape and size. Examples, stone, iron, etc. All solid material are rigid body materials. Now, in this topic, second topic, we will understand the kinetic energy of a rotating body. So for understanding this part, we take example. Assume that we have one rigid body. Their shape is shapeless body. We can take book, we can take mobile, anything. So I'm making here a shapeless body. Second, this shapeless body is rotating body. So we take for rotation, we need one axis. So we take randomly anywhere one axis. So I take axis from left side. This is my axis where we are giving this object angular velocity. Now this axis, I'm named this axis point O. This axis called axis of rotation, where whole body is rotating. Now what we have to do here, we have to find out the kinetic energy of this rotating body. So here we are making one formula. For this formula, we can easily calculate any object, rotating object kinetic energy. So we know that the object is made up of particles. Can you say that the object contains infinite number of particles? So we are considered from axis of rotation, that means point O, to one mass of the particle is represented by m1 and their linear velocity is represented by v1 and their distance we are represented by r1. Now can you hear students? Voice is coming. Hello.
Yes, sir.
Having any problem here? I hope you understand whole part. Now similarly, we are taking another particle, their mass is m2, their initial velocity is v2, and their distance is r2. But the problem is this whole body is made up of infinite number of particles. So we can't give every particle name m2, m3. So we are using the mathematics word. What is that word? Suppose this object contains number of particles. So number of particles represented by mn, correct? The number of particles is represented by mn and their distance is represented by rn. Why I'm using this word? Because this object having lots of particles. We can't calculate each particle. Now we know the kinetic energy formula. Kinetic energy is nothing but half mv square. Now in circular motion topic, we know that velocity is nothing but r omega square. I hope you remember the velocity formula. So in this we are replacing v by r omega square. So my formula become half m r omega square. Why I'm taking square? Because we have v in square form. Now remove this bracket, it becomes half m r square omega square. If you understand this part, that means we are done. Assume that we are done derivation. Now we have
सर
to calculate.
सर
Yes, yes,
सर
Prakash.
एक बार वापस समझाइए ना.
Which part? Is kinetic energy part or full body
ये
part?
नहीं सर, काइनेटिक एनर्जी वाला सिर्फ.
Acha, we already know about kinetic energy formula. What is kinetic energy formula? Half mv square. Correct, na? Now,
सर
according to circular motion, we have the velocity formula. What we are getting in velocity formula? R omega square. I hope you remember this velocity formula. So replace this v by r omega square. What we are getting? 1 upon 2 m r omega square. So what we are getting kinetic energy equation based on rotational motion, half mr square omega square. Understood this part?
यस सर समझा सर.
Now, first we are calculating all particles kinetic energy. How to calculate all particles? Suppose first particle kinetic energy is E1. So their formula is half. This particle mass is m1 and their velocity is v1. So half m1 v1 square. We know the v1 value. What is v1 value? R omega square. So we are replacing v by r omega. So what we are getting? Half m1 r1 square omega square. Similarly, can you say that kinetic energy of particle 2? Same, half m2 v2 square. Now we know the formula of v2. What is the v2 formula? r2 square omega square. Now carefully see this here, students. We are not numbering omega because omega is constant. Why omega is constant? For each particle, the angular velocity is same. Okay. So we have infinite number of particles. So can we represent by this dot 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 En? En represents the kinetic energy of number of particles is equal to 1 upon 2 m n v n square, which is represented by half m n r square n omega square. But here, student, what is the side heading? Kinetic energy of rotating body. That means what we have to calculate here. Here we have to find the total energy of body, of rotating body. So we are representing total energy. So total kinetic energy of rotating body. This means sum of all particles, because we know that this object is made by small particles. Correct. So we are adding all each particle kinetic energy, E1 plus E2 plus dot dot En. Now we have the value of each kinetic energy of particles. One E1 value is half m1 r1 omega 1. E2 का value is half m2 r2 square omega square. Similarly, and the number of kinetic energy is half mn rn square omega square. Now in this case, half is common in all these case, and see the omega is also common. So take this part common and the remaining uncommon part represented by the bracket. Okay. Now if you see carefully, what you see, the number is increasing in ascending order. First one m1 r1, then m2 r2, then m3 r3, then mn dot rn. If the number is increased in sequence form, so in this sequence is called arithmetic progression, and this type of number we are represented by submission sign. This submission sign say that the number starts from 1 and they are going from nth number. Okay, the submission sign represents the sum of the number is increases by ascending order. They start from I is equal to 1. That is why I'm representing here I and R. Okay. Now, one more case. Now, in linear motion, we are representing inertia by mass. Okay. But in rotational motion, we are representing inertia by mass and distance as well. For example, if we have hammer, so where you catch the hammer, based on this, you can feel the weight of the hammer. If you are catching this hammer at the terminal, you feel more weight. If you're catching this hammer near to the hammer, you are feeling less weight. So the mass is also depend upon the distance. Okay, students. So that is why in rotational motion, the inertia is represented by mass into distance. Now you can see here what we have, mass and distance. So on the basis of this, I am replacing this mass into distance by I symbol, inertia, and the omega square is as it is. With the help of this formula, we can easily calculate any type of body rotational kinetic energy. And here, the kinetic energy is represented by capital E. Okay, remember this one. Now, second topic is radius of gyration. Now, radius of gyration is represented by the symbol capital K. Okay. Now, what do you mean by radius of gyration? So we understand with the help of example. Again, we take any random rigid body and we take one axis. This axis, this body is rotating. Now, with this axis, we are searching those places where this whole body object mass is balanced. Now we start searching those places where the whole body mass is balanced. So suppose I'm getting from axis of rotation O to that point is M. Now from this point, my whole body mass is balanced. So from axis of rotation point O to point M, that distance is represented by K, and this distance is called radius of gyration. Now we understand with the help of definition. The distance between the axis of rotation where the whole body mass is balanced is called radius of gyration. We see the example. I make one example. We see the list. Now here in this derivation, I am representing this point mass by capital M, and we radius I am
सर आपकी
represented
आवाज
by
क्रैक हो रही है
capital K.
सर.
This is the internet problem. I know. Okay. Now my voice is cracking.
हाँ सर क्रैकिंग हो रही है.
Still cracking. What about remaining students? Can you hear my voice clearly?
Yes, sir.
No, sir.
Sayyada, my voice is coming. Khalid,
सर नहीं सर नॉइज आ रही है बीच में.
noise का problem है तो might be the problem is based on you. You are using lots of data. Because in my side, your noise is coming very clear. Now my voice is coming clear.
Yes sir.
Okay, there is an internet problem, so I'm going very slow. So I hope
सर
you
एक बार आप
understand.
वापिस पूरा समझाइए ना सर एक बार.
In
वो
simple
आवाज
word,
नहीं
I
आई थी
make
इसलिए.
one picture. So hope you understand. This is the bird. Okay. Suppose this is artificial bird, and this is my finger. Okay. Now this, what we call this point, this is their chonch wala point. I don't know the English meaning of this. So this whole bird is balanced by this their mouth part. So can I say that this mouth part is nothing but their radius of gyration? Understood? So radius of gyration is those parts in which whole body mass is balanced. Understood? So in this body, this place is that place where the whole body mass is balanced. So from axis of rotation to this place is called radius of gyration. I hope you understand what is radius of gyration. So I'm using here M, I'm representing by rotating mass of body. O is axis of rotation. Now we know the formula of inertia based on rotating body is I is equal to summation of I is equal to 1 and MIRI square. In this case, radius of gyration, I'm representing my mass by capital K and I'm representing small r by capital K. Now take this on left hand side. So it becomes I upon M is equal to K square. take this to a left hand side. So what we are getting, k is equal to square root of I upon n. See the example of radius of gyration here. Now I am balancing this bird by this their mass. It represents the whole body mass of this toy bird is balanced by this place. So for this, I hope you see this experiment. If you are not shown this experiment, check on YouTube. Okay, students. What is the SI unit of radius of gyration? Meter, and CGS unit is centimeter. Dimension is L1, M0, and T0. Now next part is the physical significance of moment of inertia. In physical significance, we compare the symbol of two motion. One is linear motion, which is already known, and we are compared with rotational motion, which is unknown for us. In linear motion, mass is represented by capital F, but in rotational motion, mass is represented by I symbol, which is called inertia. In linear motion, distance is represented by small s. In rotational motion, the distance is represented by angular distance, which is represented by the symbol theta. In linear motion, velocity is represented by small v. In rotational motion, velocity is represented by angular velocity, that is omega. Now we know the formula of force is equal to mass into acceleration. But in rotational motion, force is represented by torque, and the symbol of torque is italic T, which is nothing but mass is represented by inertia, and acceleration is represented by alpha. I hope you understand the torque formula, how we are making. Now kinetic energy, half mv square, but in rotational motion, kinetic energy is represented by ER or E rotational is equal to half. Now mass is represented by I, and velocity is represented by omega. In linear momentum, formula is P is equal to mass into velocity, but in rotational motion, linear momentum is represented by angular momentum, which is represented by L, mass, inertia, and velocity is angular velocity, that means omega. I hope you understand the symbol, how we convert this symbol. Remember this part. Now second, we are calculating torque acting on rotating body. How much torque required for any body to move in rotational motion? So what do you mean by torque? So I already tell you about torque is nothing but types of force which rotate the body. If any force which rotates the body is called torque. So that is why when we are going to shop and we are asking, my bike is not moving properly. So what they said, your torque is not proper, or your tire torque is not proper. So we are making them proper. Okay. So torque is nothing but those forces which rotate the body. Okay. Again, we are taking the same example. Let us consider we have a rigid body, shapeless, massless. Okay. And we take random axis of rotation, where this axis of rotation we name it point O, and they are moving in angular velocity, which is represented by omega. Now we know that this whole body is made up of small tiny particles. So can you guess all particle mass? Yes, of course. Suppose one particle of mass is m1, their linear velocity is v, and their linear force is f1, and their distance is represented by r1. Similarly, suppose we have one more particle, their mass is m2, their linear velocity is v, and their force is f2, and their distance is r2. Now we know that the object or body is made up of infinite number of particles. So we can't give each particle name m1, m2, r1, r2, correct? So we are representing same. Each particle mass is mn. Suppose it contains number of mass of particle mn, and then distance is number of distance rn, and their force is fn. I hope you understand the diagram. And this whole body is rotating, performing angular acceleration. Angular acceleration, that means their velocity is changing. Okay. Now we know the formula of velocity. V is equal to r omega. I hope you remember this formula. Now we also know the formula of tangential acceleration. Acceleration is nothing but change in velocity upon time. So change in velocity. Now velocity, if the velocity is changing very small, so we are represented by derivative dv upon dt. Now we have the value of v. What is the value of v? R omega. So I'm taking r d omega upon dt. We know the formula of d omega dt. D omega dt means change in angular velocity upon time. We know the change in velocity upon time is formula is acceleration. Similarly, change in angular velocity upon time formula is angular acceleration. So what we are getting here, acceleration is equal to r alpha. I hope you understand how we are getting this. If you understand this part, that means we are done half calculation, half part of torque acting on a rotating ball. Now again we are repeating the same thing. First we are calculating each particle acceleration. So suppose first particle acceleration is a1, their radius is r1, and their angular acceleration is constant alpha. Similarly, second particle acceleration is a2, r2 alpha. Similarly, we have infinite number of particles that we are representing by an is equal to rn alpha. Now we know the formula of Newton's second law. According to Newton's second law, force is nothing but mass into acceleration. Now we are calculating each particle force. Now we know the formula of force. So each particle force is represented by F1 is equal to M1 A1. We know the acceleration formula. A1 is nothing but R1 alpha. So we are replaced A1 by R1 alpha. Similarly, F2 is equal to M2 A2, which is nothing but M2 R2 alpha. Now we have number of particles. So it having number of force. So we are representing by Fn is equal to Mn An is equal to Mn Rn alpha. Now this is each particle force. Now according to definition of torque, what torque says? Torque is nothing but distance into force. Yes, true. If the distance is large, your torque is large. If your distance is low, your torque is low. So can we represent torque by torque is equal to R into F? So we are calculating each particle torque. So torque 1 is equal to R1F. Now we have F1 formula. What is F1 formula? M1 R1 alpha. So here we are putting force ka formula M1 R1 alpha. So we have 2 R1. So it is represented by M1 R1 square alpha. Similarly, we can calculate torque 2 and till torque. Now what we have to calculate? The full body torque. So how to calculate full body torque? We are adding each particle of torque, torque 1, torque 2 and torque n. Now we are adding each value. What is common in this equation? Alpha. So take alpha outside. So again the part is same. The M1 R1 is going in ascending order. So we are represented by submission sign I is equal to 1 till n mi ri square. Now we know that inertia in rotational motion, inertia is represented by mass into distance. So we are replacing this part by inertia. So we are getting this formula. In this formula, we can easily calculate any rotating body torque. Okay. The SI unit of torque is Newton meter and the dimension is L2 M1 T minus 2. I hope you understand this part, students. Okay, students, anyone having any doubt? Torque. Everyone is clear? Torque?
No, sir.
No,
Clear,
sir?
sir.
Yes, okay, that is clear.
समझा सर.
Second part is very important part. Theorem of parallel axis is very important. Most of the time, this part is coming on your board exam. Now, theorem, I hope you know about geometry, but in algebra, your math book. Theorem is a statement, and that statement we have to prove correct. So first, we understand what theorem says. Theorem of parallel axis. Suppose it is stated that the theorem states that the moment of inertia of body about any axis. So we take one random body and we make one axis. This axis is any axis which are making here, and we are represent this axis inertia by IO, and the point is O. I hope you understand this part. Is equal to the sum of moment of inertia. And what I am saying, this any axis inertia is equal to sum of moment of inertia. That means again one more inertia is coming, which is parallel to the axis. Sum of moment of inertia about parallel axis. So from this line, we are making one more line from center, which is parallel to this line. I hope you understand. Because here written is there, na? Two are equal. If they are equal, that means they are parallel axis passing through the center. But this axis is passing through the center of this small body. So I am representing this point is C at their inertia by IC. I hope you understand why I am taking the symbol C, because they are passing from the point center. Okay. and their equal and sum. The sum represents the plus sign, so I'm written here plus sign. The product means multiply sign. Mass, the product means I'm representing here mass, and the square of that. Now here I'm representing the distance by capital H, small h symbol. So the what is here written, the product of mass and the square of the distance, that is why I'm taking h square between the two parallels. What he says, from the first and second inertia both are parallel, and the product of mass and the distance are between these two parallel axes. Okay, I hope you understand the statement. So we have to calculate this equation. I0 is equal to IC plus mh square. Understood? So we are assumed here, suppose we have any mass, we are taking any place, their mass point I'm represented by P. We know that the object particle mass is very small. So object particle mass is represented by small dm. Why I'm representing the dm? Because the mass is always very, very small. So here I0 is represent the moment of inertia passing through the point O. IC represents the moment of inertia which is parallel to the this inertia and which is passing through point P. Now we know that, okay, we have less time. Now from point O to C is represented by the symbol H. So value of OC is H. Now from O to P point is the distance is represented by small r. Similarly, from point C to P, distance is represented by R0. CP distance is represented by R0. Now we are doing construction. From point P to D, from point P we are taking one straight line, and from C we are taking one horizontal line, and we are meeting one point D. From C to D, distance is represented by X. So CD distance is construction part, we are representing by X. Now we know that the OP is nothing but, I hope you understand this part, diagram part. Now we know the formula.
Yes, sir. Samjha.
Okay, very good. So inertia formula based on IO is, now IO, how to represent inertia formula? The inertia formula is always represented by distance and mass. So IO distance is R and their mass is dm. So can we say that OP? We know that R is always in inertia. What is the formula of inertia? mr square. So we represent distance by square from, so OP square dm. So in inertia, in this concept, we are represented by integration. Okay, remember this part. So we know that OP is nothing but R square and the mass is dm. So here IO ka value is R square dm. Remember this part. Similarly, IC ka value is, how to calculate IC ka value? CP into mass. So CP square into dm. CP is nothing but R0 square dm. Remember this part because we are putting this part in for calculating this equation. So we know that in triangle OPD, see here one angle is made, triangle OPD. So I'm making this triangle here OPD. I hope you see this triangle OPD. This is not, this is based on CBD. So I'm making OED. Now we know that OP is R, and from O to D, we have one more point C. From OC is distance is H, and CD is distance is H. Clear? And point P mass is represented by dm. Now first we take OPD and we are applying the theorem, which is called Pythagoras theorem. So what is Pythagoras theorem? Okay, some family fighting we can hear from here, students. So please mute your voice. Now in triangle OPD, what is Pythagoras theorem? OP square is equal to OD square plus PD square. Okay. Now in OD square we have two parts, OC and CD. So can we represent OD by OC plus CD? I hope you understand. And this PD part is as it is. Now this part is represented by A plus B whole square formula. So we know the formula of A plus B whole square, and we are applying this formula plus here OC plus CD. What is the formula of A plus B whole square? A square plus B square plus 2AB. Correct? So we are applying this formula here. So what is the formula of A plus B whole square? OC square is my A and CD is my B. OC square plus CD square plus 2OC CD. If you understand how we are calculating this part, and the PD part is representing by PD as well. Now that this small triangle, can you see this small triangle PCD? What is PCD? PCD ka we are again finding the Pythagoras theorem because we are removing this part. So what is Pythagoras theorem? PC square is equal to PD square plus CD square. Now what is the value of PC is R0 square. What is the value of PD? We don't know the value of PD square. So leave it. CD square value is X square. Understood? Take this X square left side. So we are getting the value of, I think I'm taking the wrong way because both value is on the plus form. No, I'm taking correct way. So we know that this hypotenuse represent the two values, PD and X square value. Correct now? So here we know that what is the value of CD? CD value is X. So we are replacing by X square.
X.
Correct. So X square and PD is can be represented by R0 square from this equation. PD plus X square is nothing but R0. Correct now? So I'm replacing this X square plus PD square by R0 square. Similarly, what is the value of OC? OC we are representing by H symbol. So H square. 2OC, OC represented by H and CD is represented by X. CD is X square and PD we don't know. So we are replacing whole part. We are very near to our equation part. Next, what we do? Rearrange it. Take R0 first, then H, then 2H. Now multiply by dm. Now what you do? Multiply by dm as well as integrate this one. So we are integrating as well. We are multiply by dm. I hope you understand this part. So we know that IO is nothing but integration R square dm. Remember, this is the value. So replace this R square dm by IO and R0 square dm by IC. We know the IC value. Integration R0 square dm. Correct? We know that H is constant, so take outside. We know the integration of dm. Integration dm is nothing but capital. So it becomes mh square. And this hx dm coming from the center part. We know the CD, where is CD? So we see here. CD and hx is represent the center part. And we know that the center of mass is always 0. So we take this whole part as 0. See, we are getting we prove the theorem I0 is equal to IC plus M square. Any student having any doubt from this theorem? This theorem is very important based on board exam. So can we go further? Okay, we are going further. Second theorem is theorem of perpendicular axis theorem. What theorem says? The theorem says
Sir, time नहीं है अभी sir.
We have time, 3 minutes. I hope we cover this theorem too. Or we will stop here. Okay, no worry, we will stop here and we will deal this theorem on tomorrow. So I am giving you assignment, but very few students is doing assignment. Still, the few students coming here. So tell the student we are taking your attendance. Okay, students, because physics is.
Sir,
I hope.
सर मैं गांव में हूँ तो बाद में कर सकता हूँ सर.
What?
Assignment.
Assignment.
सर अभी मैं गांव में. हाँ सर.
हाँ, okay.
Yeah, thank you sir.
But you have notebook ना? Your village don't have a stationery. ट्राई करो एटलीस्ट ट्राई करो, अगर मिलता है तो अच्छा है. ओके, तो आज फिजिक्स का असाइनमेंट भी मिलेगा. यू आर गेटिंग फिजिक्स असाइनमेंट एज वेल एज मैथमेटिक्स असाइनमेंट. ओके, एक्सरसाइज whatever we done, and I give you the answer too. Okay students, if you need answer I give you the answer. Okay, anything else? Anyone having any doubt here? And don't leave the class because I'm not done screenshot. Now I'm taking screenshot. You are present. So if someone leave the class having problem, so see, I remember today lecture I'm taking your physics lecture. See, today date is, what is the date of today? 30 na? 30.
30.
Yes, sir.
30. So I'm writing it 37, 20,
अच्छा
and
sir, right.
today date is Thursday, correct? Thursday. Okay, now I'm saving this part. Where I'm saving here music part. This is physics. Date is 37, 20. So see, I save your attendance. So lots of few students. And what about the girls? Where is the girl? Sayyada is only there. Sayyada, one girl is there. I hope other girls is very smart. Sheikh Naman, Sayyada, Musa, Talib. Okay. Okay, we will leave the lecture. Now connect it automatically turn off your lecture. If you need recording part, I'm recording this video. Okay? If anyone want a recording video,